In this video, we're going to learn about half-life. A lot of radioactive substances, we learn about their half-life, and we can use that to answer questions about how long it's been around. One formula that we can use for half-life is given here. So you have A sub t, which is the amount after time, equals A sub 0, which is the initial amount, times 1/2, because we're talking about half-life, to the t over k power. T is how long it's been since the substance started to decay, and K is the half-life of that substance. So let's take a look at how this formula works. Our essential question is, how do I apply exponential and logarithmic models to solve problems? Same essential question we've been working with for a few days now. Taking a look at our first question, we know the half-life of the element, we know how much is left, and we know how long it has been decaying. So the question is, how much of the substance was around initially? So setting up our formula, we have A sub t, amount after time, equals A sub 0, initial amount, times 1/2 to the t, time, over k, half-life, power. So the amount after time in our case is 3 grams. The initial amount is what we're solving for. I'm going to drop the sub 0 so it doesn't mess us up and just call it A, times 1/2 to the t is how long the substance has been decaying. So in this case, it's 10,000, divided by k is the half-life, 3,685. To solve this, all we need to do is divide by 1/2 to the 10,000 over 3,685 power. That whole thing is one value. We could put that into our calculator and get a decimal, but I prefer to do that last so that we have the least amount of rounding error. So dividing both sides by 1/2 to the 10,000 over 3,685 power will give us our initial amount. When you punch that in your calculator, I recommend changing the 1/2 to a decimal, 0.5, and putting the parentheses around the power instead. So I got approximately 19.68 grams. Using that information, we can then answer how much will be left after 20,000 years. Substituting that value into our formula, A sub t equals our initial amount times 1/2 to the t over our half-life is 3,685. So now the two variables are time and the amount after time. In this case, we know the time. We're solving for how much will be left. So we're going to substitute 20,000 for t. So this is A sub 20,000, or the amount after 20,000 years, equals 19.68 times 1/2 to the 20,000 over 3,685 power. This time we have all of the values on the right-hand side, so we can just punch this into our calculator. Again, I would use 0.5 instead of 1/2 and put parentheses around that power. And I got about 0.457 grams. One last question. This time we know a percent remaining and not an actual value, so we need to think about this a little bit more carefully as we set up our equation. Starting with that same equation, the amount after time equals our initial amount times 1/2 to the time over k power, k again being our half-life. So if we have 35% remaining, we need to solve for how long ago was it made. So we need to solve for t, which means the first thing that we would do to solve for t is divide by the initial amount. So I'm going to start by substituting in our half-life. Even though we don't know the amount after time and we don't know the initial amount, we do know our half-life is 2,500. So again, starting by dividing by that initial amount, if you think about this, the amount after time divided by the initial amount is what will give us the percent of what's left. So we're going to substitute 0.35 for that value. Now we have only one variable left, and we can solve for t. Remember, when the variable is in the exponent, in order to get it out, we're going to use that power rule with logs. So we first need to take the log of both sides. You can either use the common log or the natural log. I'm going to start by taking the natural log of both sides. On the right-hand side, I'm going to use my power rule and bring that exponent as a coefficient. So we've got t over 2500 times the natural log of 1/2. Next, I want to get rid of my variable, so I'm going to multiply both sides by 2500. And that'll leave me with t times the natural log of 1/2. And then I can divide both sides by the natural log of 1/2 to cancel it on the right-hand side. And that'll give me my t value, which is about 3,786.433 years.